Alright, welcome back to the last lesson for this week, and this is on something called acid and base indicators. So we're going to go over what they do, and then of course how to predict pH of solutions based on indicator color. So of course, what is an indicator? So what this is, an acid-base indicator, is a substance that changes color when the pH of a solution changes. So indicators exist in two forms that have different colors. Now there's a handful that might have three different forms, but we'll kind of cross that bridge when we get to it. For the most part, there's just two forms of an indicator and they have two different colors. Now, acid-base indicators are very complicated molecular structures, so we're not going to use chemical formulas. We use abbreviations to identify the indicator. So for example, just a general indicator, we're just going to use the abbreviation big I little n, so IN for indicator. Now, if you see H in front, H meaning acidic, this is the lower pH form, meaning that it's more acidic. And if we see IN with the minus, kind of like bases and stuff like that, this is the higher pH, or the more basic form. So of course you do have a bunch of these on the back of your periodic table. Now this isn't the one exactly what you have, but it's very similar, where you have acid and base indicators. So we have the indicator name, the suggested abbreviations here. So like for methyl violet, we see MV for methyl violet. In the acidic form, we see HMV. For the basic form, just MV minus. All right. So all these here have their abbreviations. Just like that. Now, one thing you will notice is litmus is not on your chart, neither is it here, but I'll just show you. Litmus is LT. Now, we know the pH range of litmus, or you know what it does. We can tell if something's neutral, acidic, or basic, but the pH range for litmus is between 6.0 and 8.0. What that means is that anything below 6.0 is going to be HIN, or in this case right here, the acidic form is HLT. And of course we know when litmus is in the acidic form, we see red. Same thing if it's in its basic form, we know litmus is blue. Now this is why if you know the pH right in between 6 and 8, well 7, and that's why litmus, the red litmus paper doesn't change color at 7, nor does the blue change color, because 7 is right in the middle of the pH range. It's only going to turn red if it's below a pH of 6, it's only going to change blue if it's above a pH of 8, and a pH of 7, nothing changes color. So that's why litmus is used to determine if something is acidic or basic. Now for bromothymol blue, this one is you're going to need to use your data booklets, or the back of your periodic table. So if we try to find bromothymol blue, we'll notice bromothymol blue is right here. So I'm just going to highlight all the important stuff for bromothymol blue. So the acidic form is HBB, the basic form is BB, but more importantly, the pH range is 6 to 7.6. So we can fill in some of that. So the abbreviation, capital B, lowercase b, and 6.0 to 7.6. So that means any pH below 6.0 is in the acidic range. Now for bromothymol blue, that is this one right here. So this and this matches together. And just like the 7.6 and the blue are going to match together as well. So that means anything below 6.0 is going to be yellow. Anything above 7.6 is going to be blue. If it's in between, there's going to be no color change. So we have yellow for the acidic and blue for the basic. And finally, the phenolphthalein. If you want to pause this video and try to fill out the phenolphthalein one for yourself, please do. But you'll find phenolphthalein is down here. So the abbreviation is pH. It has a range of 8.2 to 10.0, and the color change is colorless to pink. So that means anything below 8.2 is going to be colorless, anything above 10.0 is going to be pink. So we can fill that in. We got pH, and the range is 8.2 to 10.0, colorless to pink. So you'll notice a lot of the things there, they do range from extremely acidic to basic, and this is why we have different indicators. So we're going to change at different colors. So this is, if we use a bunch of them, we can kind of narrow down the pH range of certain solutions. So what acid and base indicators are used for is to mark the end of titration, which we're going to see later on in chapter 8, so unit 4, and to estimate the pH of a solution, which we are going to use for this one. So this replaces the work of a pH meter, but of course it's not as accurate. Yeah, that was it. All right, so for this one right here is predict the indicator color at the specific pH. So just a little hint, if it is in the pH range, you will see a mix of both colors. So that's because like it's kind of on the way of changing. So how we use, of course, this chart right here, bromocresol green at a pH of 2.8. So we go to the back of our periodic tables. We find bromocresol green, which is right here. Now we'll notice its color change is 3.8 to 5.4, and it goes from yellow to blue. Now the question's asking for what is it going to be at 2.8. So we'll notice 2.8 is below our 3.8, so that means we should see a yellow color. So if you think that you can get the rest of them, just pause the video and fill them in and see if you get them. I'm going to do the phenol red and then just kind of fill in all the other ones that you should see. So the phenol red at 8.5. Same thing, we find phenol red on the back of our periodic table here. So phenol red is right here. And we'll see the color change is yellow to red. So anything below 6.6 is going to be yellow, anything above 8.0 is going to be red. And of course 8.5 is above 8.0, so we should see red. For our cresol red at 8, same thing, we find cresol red, which is up here. So cresol red is right here. Now the one that we are asked is for 8. Now we'll notice that it is right in between here. So 8 is in between 7 and 8.8. So that means we're going to see a mixture of yellow and red. Then of course you can write yellowish red or reddish yellow. The fact that it's a little closer to the 8.8 than a 7, it might be more red, but either way we're going to see a mixture. So you would expect to see an orange color. All right, and then of course the last few, we see yellow. And for methyl violet, we're going to see a mixture of yellow and blue for a green color. So that is kind of how we can predict the color of a particular indicator at a certain pH. Or, like I say, we can use the colors given to us to estimate the pH of a certain solution. So this is an example right here where we have 4 different indicators with different colors. Now, normally we would do a lab based on this as well, but just due to circumstances, we can't actually do the lab. So there are some examples inside of your workbook with questions like this. So based on the color it's given, we are just going to highlight if the pH is going to be above or below a certain unit, and then we're just going to try to narrow in the gap. Because remember, our pH scale, right, goes from 0 to 14, and right in the middle we have a pH of 7, right? And then of course we have all the intermediate steps in between. That's going to have the pH scale look. So from our evidence here, we're just going to see the pH range, and we're going to try to fill it in kind of on this mock little scale just so you have another visualization of how it looks. So with our orange 4, it's yellow. All right, so what this means, we go to the back of our periodic table and we find orange 4 is right here. So yellow means that the pH is going to be above 2.8, all right, because that's what a yellow color for orange 4 means. So we know from this one right here, with our orange 4, I'll just write this in here. So orange 4, pH is greater than, was it 2.8? So that means from our orange 4, it cannot be anything below 2.8, right? So our pH range with our orange 4 right now is basically anywhere between here and above, right? So this kind of narrows down our orange 4 is everything above here. But we know our pH cannot exist here. So we can kind of scratch out this little area of our pH, right? So if this is 2.8, because that's what it means by pH is greater than 2.8. So when we look at our next one, we see bromocresol green is blue. So we'll find bromocresol green here. And blue, the color right here, that means the pH is above 5.4. So we can go back and kind of mark off 5.4 is about right here. And what that means now, because the pH is anything above this here, so now we can kind of scratch out this entire section right here because it can't be anything below 5.4. Right, so right now we're just kind of eliminating this entire portion of our basically pH line here. Just let me fill that in here. Greater than 5.4. Now our next one, our phenol red. We see a yellow color. So we go back, we figure out what does phenol red mean. So we find our phenol red, which is down here, and it says that is yellow. So yellow is right here, meaning that it is below 6.6. So it cannot be above anything 6.6. So we're going to go back, and if we had our 6.6 is here, and we need to be below that, that means that all of this area up here, the solution cannot be in that. Because phenol red is saying that the pH needs to be below 6.6. So you can tell right here we have this very narrow range because our first two indicators told us that it needs to be above 5.4, and phenol red is saying it needs to be below 6.6. So we'll see if bromothymol blue tells us anything different. Bromothymol blue says it should be yellow. So what does that mean? We find bromothymol blue is here. Yellow is right here. That means it needs to be below 6.0. So that means it's below 6.0. So that means our cutoff point right now is here, 6.0, and that eliminates this section right here. So now what we can see, the only area of our graph that is not basically crossed out is we have this area right here. And our pH range is here. So the unknown must be between a pH of 5.4 and 6.0 based on the information that's there. So this is kind of visually how you can kind of draw out a complete pH line and just start crossing off areas that it can't be, and then whatever gap you have left, that is the pH range based on the solutions. So that's kind of how you can use these here to figure out a pH range. Now, like I said, there's a bunch of different examples inside of your workbooks, so please try those. If you have any troubles, once again, make sure to email or save your questions and make sure to log on during our extra help sessions on Thursday at 9:30. Anyway, that is it for this week. So I'll see you guys later when we'll finish off actually our solutions unit. So see you guys then.